Hi viewers, this is Sri Ramlu and today's topic is very important, that is continuity equations, right? So don't forget to watching this video and subscribing it. Continuity equation. First, what is a continuity equation? Definition. The differential equation which gives a functional relationship between concentration of carriers with time and distance is called continuity equation. Okay, so continuity equation is a differential equation, it is right, it is a differential equation and it gives a functional relation. So that means it gives a relationship between time and a distance. So that is why it is called continuity equation. Okay, it is a functional relation between concentration of carriers with, that is with time and distance. Time and distance, both things present in the equation. Now consider an infinitesimal semiconductor element of length dx and a cross-sectional area A as shown in figure. See here it is shown in figure. So it is infinitesimal small, it is an element. So that means it is a very small cube having the length. Its length is how much? It is the length is dx and area is A. Let P be the average whole concentration within this volume. So in this volume P is what? P indicates concentration of, it is average whole concentration, means number of holes has to present per unit volume, that is a concentration. Next, considering the problem only one dimensional. So here I am considering in one dimension only, that is along x-axis, one dimension. Let current entering the volume at x is IP. Okay, so at x is IP at a time t. So at the time is t, while at the same time current leaving the volume at a distance x plus dx is I plus dip. Okay, so when the current is entering into the volume is IP, at what distance? At x distance, and after traveling a certain distance, that is how much distance? X plus dx, means dx distance is traveling. After traveling dx distance, a small amount of current will be added to IP. That small amount of current is what? dip. So it is because of it is whole concentration which present inside the small u volume. Okay, thus more current leaves the volume for a positive value of dip. So that is why outside coming current is somewhat greater than the incoming current. There will be a change of concentration due to the following factors. So concentration will change because of following factors. So these three factors are very important while deriving the continuity equation. So what are the three equations? Let me explain one by one. Concentration of holes decreases due to additional current dip. When current flows through it, then what happens? Recombination process will take place. So combine or holes concentration will decreases. Holes also has to move. So when holes moves, then holes inside it decreases. So that is why, because of this additional current, what? Holes concentration decreases. Next, when decreases, concentration of hole increases due to the thermal generation. Because of temperature, hole concentration increases, means electron hole pair generation will takes place. When electron hole pair generate, one hole will create. So like this, one electron will create. So like this creation, then concentration what happens? Increases. Next, concentration of holes decreases due to recombination. So now the holes are generating, and after certain time what happens? This hole may combine with the electrons. So that is called recombination process. So recombination, because of recombination process, whole number will decrease. So that is why their concentration decreases. Okay, so here only in one case whole concentration increases, and remaining two cases whole concentration decreases. So those are the cases are, one is decreasing cases are recombination cases, and because of additional current. Increasing cases because of thermal generation, means because of temperature electron hole pair will generate. And next, let us consider. So see, let me see the above factors in derivation form. Let us consider the factor one by one. First one, there is a decrease of current dip in the volume. That is, there is a net decreases in the concentration of holes. The decrease of hole per second. So how much it is decreasing? Decreasing is denoted by minus, right? So decrease indicates that is a minus. Dip by E, where E is what? See here, where E is the magnitude of charge. If it is electron, magnitude of electron. If it is a holes, that is a magnitude of holes. So the so the decrease in hole concentration. So concentration definition is holes per unit volume is a concentration. So per unit volume, how much holes are there? That is called concentration, holes concentration. Okay. So the decrease in hole concentration per second due to the current is, due to which current? DIV current is how much? Per unit volume. Per unit volume means current by volume. DIP by volume. Volume is written as area into length. Already this length is given, dx length. So it is volume. So volume is written here. Okay. And is as it is, whatever taken here, that is. And now one thing here we have to change. I current by area is called current density. It is denoted by J. Okay. This current is holes current. IP by A is JP. Okay. Current density due to hole. So that is why here it is written. Okay. It is the first two. So it is decreasing. Next, increasing, decreasing. Now see what is this. Due to thermal agitation, means change in temperature. Agitation means because of change in temperature, the electron hole pairs are generated. Just now I explained you. So suppose the electron is there, so that is a combined, that is under attraction of nucleus. If you supply the small amount of thermal energy, then okay, because of thermal energy, what happens? This hole come outside. So when it is coming outside, here vacancy will create. That vacancy is called hole. So when electron come outside, vacancy will create. That vacancy is hole. Like this, whole electron pair will generate. The generation process always increases the charge carrier concentration. Yes. So carrier concentration means a hole's concentration or electron concentration will increase. Means number of electrons or number of holes increase. Let the thermal generation increases the number of holes at the rate of G. So let the rate of G means per time how much holes are generating, per 20 seconds, per 30 seconds how much holes are generating. So that is the rate of G, we have to say. Rate of G is okay. Generation stands for G. Holes per second. The generation rate is given by generation rate is P naught by tau P. Why it is a P naught? See here, where P naught is the concentration of holes at the thermal equilibrium. Tau P is the mean lifetime of holes. What is the meaning of mean lifetime? Mean lifetime means now electron holes are generating. Okay. So and after certain time, what happens? Again they recombine. This during this time, generation and recombination time during this time is called mean lifetime. Okay. So that is the lifetime of hole. A mean means average lifetime. Right. So okay, P naught, it is a generation. Next, due to the recombination process, the concentration of holes in semiconductor decreases. Yes, due to the recombination, what happens when electron comes and it attract or it combine with the holes, then what happens? Hole disappear. So that means recombination. That is we call recombination process. Okay, due to the recombination process, concentration of holes in semiconductor decreases. The decrease of hole per unit volume per second is called recombination rate. Okay, here rate indicates time, and it is given by R is equals to P by P naught. Why it is P by tau P? Tau P and here tau P same, means generation, for generation how much time takes? Recombination time is also same. And it is a beginning P naught and it is after some recombination. Okay, so it is generation, it is recombination hole, where P is the concentration of hole after some time, that is. Now we know that the charge can neither be generated nor be destroyed. The increase in hole concentration dou p by dou t must be equal to the algebraic sum of the above described factors. Okay. Here holes are charges. Yes, we know that is. But according to law of conservation of charge, what is holes neither be created nor be destroyed. Okay, so that is why their algebraic sum is always same. So here algebraic sum. So for rate for time it is also dou p by dou t is equals to g is a generation, it is increasing, r is the rate of recombination decreasing, and this is a what it is due to the additional current what happens, holes concentration decreases. So decreasing values are with a minus shown. Okay, so g is a plus means increase, and r minus and dou j p by dou x is decreasing. Two factors decreases, one factor increase. So that is a two factors are attached to with minus, one is plus. Okay, now substitute g value here and r value here, and it is as it is. So already we know g value, r value, g value p naught by tau p, r value is p by tau p. See here, g value is p naught by tau p, and r value is p by tau p. Tau p. Okay. Now, so here a tau p is common. So take a single tau p and write it is like this. So it is equation 1. Okay, now we are going to calculate jp value. So if you calculate jp value, then if you substitute here, then that is a contrary equation. So for this, what I am doing, I am going to consider the two things. One is a diffusion, other one is drift and a diffusion. So drift and diffusion also explained in the previous one video is there. So please that video. So I will keep its link. I will provide a link of that video. Okay friends, now see. So there I explained how this formula comes. We know that current density due to diffusion for hole is given by. Diffusion means what? So diffusion means, actually if you take any semiconductor device which is a extrinsic semiconductor, suppose it is not doped properly, this is a semiconductor device not doped properly, so this side heavily doped and this side is lightly doped, then concentration is high here and concentration low is this side, then charge carriers can move from higher concentration region to lower concentration region. This process is called a diffusion, and while it is moving in this direction, distance increases. When distance increases, what happens? Concentration decreases. So that is why here minus we will attach minus. Okay, so here actually j is current density is what? Directly proportional to dou p by dou x. Actually dou p by dou x, it is a gradient we call. Which gradient? Whole gradient we call. Okay, so if you remove the directly proportionality, we have to keep dp, and E is attached, it is a charge of hole, and minus indicates decreases when distance increases. dp is diffusion constant. So while removing directly proportionality, we have to take one constant, that constant is taken as dp only. Okay, actually it is what? Once again, jp is directly proportional to dou p by dou x. jp, if you remove the directly proportionality, we have to take equal and constant, that constant is dp, diffusion constant for hole, dou p by dou x. Okay, but here E attached, why it is indicates charge, and a minus why? When distance increases, it a concentration decreases, so that is why minus. Okay friends, next, current's density due to drifting means actually suppose it is a crystal like this, positive cores are there, when electron is coming from this side, or one charge hole is coming, or any electron hole coming, so when it attracts and again starts moving toward this side, so because of electric field, then what happens? Electric field, then what happens? Their velocity is here, velocity increases and decreases, velocity increases, decreases. Okay, this is called drifting. Okay, like this drifts, and this drift j is directly proportional to actually concentration of hole, mobility of charge carriers, and electric field. Okay, so holes increase, if hole increases, density increases, Mobility increases, density increases, field increases, electric field increases, then also density increases. Okay, where mu p is the mobility of hole and is the strength of applied electric field. The total current density for the hole due to the diffusion and drift is given. So diffusion and drift is simply Jp. Jp is what? It is a negative one, it is positive. So the values are substituted here. Let it is equation 1. 2. Substitute the equation 2 in equation 1. So where Jp it is in the place of Jp, substitute this Jp, then simplify, then we get here. So it is equation 1. In the place of Jp, equation 2 is substituted. So multiply dou minus dou by e dou x inside. Then it becomes, so it is multiplied to this one and it is multiplied to this one also. Now it is constant, take outside, and instead of constant, suppose it is e value gets cancelled here. Here e value, this e value again cancelled. Okay, here dp is come outside, and now next dou by dou x into dou p by dou x becomes, and e cancel here. Mu p is constant, come out, bring outside, and I write it like this only, p e. Now dou square, dou x square, right? So dou p by dou t, it is as it is, p naught minus p by tau p plus dp dou square p by dou x square minus mu p dou by dou x p e. Okay, so here minus plus, don't forget this one. So this is the continuity equation for hole. Similarly, in the place of p, if you substitute n value negative, then that is the equation for continuity equation for electron, right? Dou n by, so in the place of p only, in the place of p substituted n, dou n by dou t is equals to n naught minus n by tau n plus dn into dou square n by dou x square minus mu n dou by dou x into ne is called continuity equation for electron. It is a continuity equation for hole. Okay friends, thank you. So don't forget subscribing this video. Thank you.